Hello students, welcome to eLessons. I am Zihana, your chemistry teacher. So students, another important factor that you need to know about the valence bond theory is that it gives us an idea about the orbital overlapping with respect to whether it is positive, negative or zero. So what are the three cases that can arise? It may be either positive or negative, or it may be zero. Okay, so when does each of the scenario happen and why does it happen? So why are we considering it to be positive, negative or zero? We need to know that as well. It depends on the direction and the amplitude of the overlapping orbitals. So whenever the orbitals that are forming the bond have the same phase or the same direction and they form a bond, then it is called as positive. Okay? In cases where the signs are different, there it is called negative. Okay? So when does it become zero? Whenever the orbitals are not overlapping in the correct condition or in such a way that they do not have a proper interaction, then that case becomes zero. Now let us have a look at a couple of examples where the s and the p orbitals will overlap and we will be able to differentiate whether it is positive overlap, negative overlap or zero overlap. So the first case scenario, let me consider the axis, okay, of bond formation to be Z. This is my one axis. The other axis I will draw now. Okay. So this is case A and this is case B. So in case A, what happens students? I am going to show the orbitals, that is the p orbitals forming a bond, two different p orbitals from two different atoms coming together here. Okay. So first of all you know and you remember that p orbital is always in the dumbbell shape, correct? So this I will call as my p orbital. And now I am going to show you another p orbital where there is slight overlapping happening. Okay. So this is my second p orbital. Now I'm going to assign signs to these orbitals. First of all, we will give this as minus and this is plus. Okay, and the second one, this is plus and this is minus. So in this case, if you observe here, the plus charges, the like charges are overlapping against each other or on each other. So in this situation, we call it as a positive overlap. Okay, now let us have a look at the second case scenario where the same thing is happening. We have two different p orbitals from two different atoms being overlapped. Okay. Now let me assign the signs to it, students. So we have minus, plus, minus and plus. If you observe here, the opposite signs have overlapped on each other. So in such a case scenario, we will call it as negative overlap. Or in other terms, it can also be called as this is phase in or this is phase out or out of phase kind of overlap. Okay, this was one of the cases. Alternatively, what can happen is If now this I have shown you where the axis is z and the axis of their orientation is also on the same line, right, same phase. But in case if the p orbitals were like this in this axis, another p orbital, let me show its overlap. Okay, so the p orbital is being overlapped on the other p orbital in this way, and these two are positive and these two are negative. So this will be positive overlap. In another case, a similar situation, if I were to show you here, and I have another p orbital overlapping it this way. Okay, if this was the case scenario and the signs were opposite, that is here it is plus, here it is minus, here minus and here plus, then this is called as negative overlap. Okay, now let us see what happens when the p orbital and the s orbital are going to overlap. How do we get the positive and the negative?